All right, good morning. I'll be the first presentation for today, Tuesday, August 11th. Our presentation for CINR, the NEAP call, is going to be focused on fast reactor technologies. I'll go through a few slides, and at the very end of the presentation, there will be identified technical POCs and my email for reference. So as you, I believe we're holding questions till the very end. So as you have questions, hold them, and if you continue to have issues or questions during the call, please reach out to myself or Chris Grandy. Our program mission and objectives. Our mission is to perform targeted research, create sustained technical infrastructure to support demonstrations of U.S. fast reactor technologies and to enable subsequent commercial deployments. I've listed 3 objectives here, and also some of the hardware. Many of you, as you can read this slide, can pay attention to the hardware that is identified here for at METAL, which is at Argonne National Labs, just south of Chicago. This isn't just an R&D or concept or study. This is actually us working with the universities to make experiments, to perform and collect data and information, and to put them into the METAL facility, which you see on the left. The rightmost picture, PDF, is the GTA that we built over the last couple of years, and we've put it in sodium for active testing and collected data and information. One of the shortcomings that we do have, and just in our nuclear industry, is that when we make these experiments, we try and put them in their practical environments to sort of re-engineer some of the information that we've lost in manufacturing these components. We learned a lot from this assembly, and that's why we're asking for additional information through this call to have the universities assist us in some of the other avenues that we see. Slide 3, our major R&D program areas. For the commercial deployment of fast reactor stakeholders have identified 2 recurring challenges. Now, again, as you read these, realize that we are working with industry very hand in glove on these to make sure that we are answering their needs. And they have identified capital investments as a dominant cost in this issue, and a pathway must be established for non-light water licensing. We do have approaches that you should be aware of through the Licensing Modernization Project, LMP, and TCAP have started. So when you go forward, we're building on some of those platforms. If you're not aware of them, myself or Chris Grandy can provide more of the information under LMP and TCAP, TICAP, as you need. To address these challenges, the program uses input from stakeholders such as the industry-led fast reactor technology working group to focus its efforts on the following R&D areas: preserving, streamlining access, industry outreach, which is what I discussed earlier, and utilizing METAL. Improving, sustaining benchmarking and validating existing reactor designs, and providing technical basis to support AS&E qualifications. All of these are very critical to us. And please, when you submit your applications, your proposals, please focus on these areas as you're making your proposal and developing it. Slide 4. Our specific call for RC-3, liquid metal cooled fast reactor technology development and demonstration to support deployment. Now, this is very specific. Again, this is not a study or a loose R&D. This is very specific to the needs that we need in our organization to move forward. I think for many of the university people, especially people who are looking to get commercial space, hiring, these are activities that you could really focus on and help us as this program starts to mature. So focus on technology enhancements and experimental work that can offer potential significant benefits in reactor capital or operating costs. This is the second time we've brought this up. These examples, now these are examples, they're not all inclusive, they're just an example that we've provided. Development of test articles for METAL. Test articles can be used to demonstrate innovative subcomponents or validate key fast reactor behaviors under prototypic conditions. Enhancement of advanced sensors and instrumentation required to operate in a primary liquid coolant. I will tell you that when you start to go down this path of number 2, be very aware of temperature, corrosion, and time that these sensors will be able to survive in an environment. There are other issues that you may have to address, whether it's a hard line, potential coming through the vessel, if it's a remote access. Some of those activities may have to be coordinated and questions asked to the technical POC to make sure that you understand the exact call there. Number 3, testing components for innovative liquid metal cooled reactor self-actuated control and shutdown systems. Number 4, experiments for in-service repair technologies. These systems include visualization sensors for immersed coolant applications and technologies for the welding and repair of structures in contact with the primary coolant. Again, those are 4 areas of examples. They are not all inclusive. If you have questions of whether or not your proposal fits in, please reach out. We certainly will take emails or calls to answer these questions. Slide 5. Continuation of the examples, 3 more. Improving performance of metal, sodium technologies, including rugged, high-temperature resistant heating systems, improved insulation technologies, improved sodium leak detection and identification technologies, vessel support technologies that reduce heat loss, improve clamp on-flow meters, thermal monitoring, smaller and more compact refueling systems. 6, development of deployable sensors and prognostic techniques for the demonstration of metal that can be used to monitor the health and quantify material degradations in liquid metal cooled fast reactor primary systems. 7, development of thermal hydraulic test articles for gathering data for thermal hydraulic code validation in a prototypical environment. Again, at the very end of this, there's a hyperlink provided for further information under what metal is, maybe how you can tailor your experiments to go forward, and you can find it at the end of the slide. Slide 6. We have our technical POCs. I'm at the very top, Brian Robinson. I will be available through either one of these mechanisms. I will tell you that the one that probably is the best way of reaching me is through email. Technical POC is Chris Grandy. He can be reached through both of these resources also. At this time, I believe that I have completed the review and will table questions. Drew?
Hi, Brian. This is Julie, and I'm going to go ahead and read the questions for everybody. The first question we have is for RC-3. Is bearing and seal development and high temperature tribology of interest?
Bearing, seal, and tribology. Yes, I think that would be interest with us. Again, for areas like this that haven't been called out in our examples, I would really point back to the technical POC. The difference with the technologies as we handle fast reactors, chloride reactors, high temperature reactors is the R&D in those areas have moved at different pace, and they're not always complementary to each other. So by reaching back to the technical POC, you will understand what's been proven and what areas that we're needing to advance on so your application will find the right space. Does that answer the call?
I think so. They can write a follow-up question if not. Our next question is, are oxygen sensors to monitor liquid sodium of interest?
Again, I hate to keep having this going back, and yes, they are. Really, I would ask, is Chris Grandy available on the line? Does he have audio support?
We'll check for you.
Okay. I would ask if Chris is being checked, see if he can respond, that chemistry control is always an issue when you're dealing with these systems. So again, I would ask for you to, before you write a full proposal, to contact and talk to Randy about details of what technology you're promoting, so we can give you the best answer for you.
Yeah. Hey, Brian, I'm here. This is Chris Randy. Can you hear me?
All right.
Okay?
I got you.
Yeah. So I would agree with your comment. Obviously, bearings and seals are important to applications to SFRs. It depends on the overall component you're talking about, and then O2 sensors are also important for this technology.
And Chris, I don't know, were you able to respond to the need for oxygen sensors? Sorry, Julie.
That's okay.
So the O2 sensors, those would be helpful also. I think what people need to understand is that they need to understand what the base technology is, right? Meaning the technology that's been done in the past, and what we should be able to create again, and how their proposed technology improves upon that.
Yeah. Julie, just so people know, kind of my thumbnail on fast reactor technology, other than light technology, it's probably one of the most amassed, detailed information that we have. Under the course of about the last 60 plus years, a lot of that information has deteriorated, and a lot of the knowledge to construct some of these components have also been lost. So that's why I think it's very important for everybody who wants to submit, sure that they understand what is being resurrected, what needs to be continued to be researched, and that the only way to really do that is to reach back to Chris Grandy on that information. Julie, back to you.
Okay, next question. Are innovative high temperature neutron detectors included in advanced sensors?
I'm going to let you answer that, Chris. You first.
So is that for like detecting the flux coming off of an SFR? Is that what they're talking about?
I'm sorry, I'm kind of losing the audio.
Yeah.
Yeah.
Can you hear me better now?
Yeah, I think that was a little better.
Yeah. So if what they're talking about are detectors to detect the flux coming off of an SFR, this call may not be associated with that particular type of application.
So Julie, I'm getting internet sort of audio on Chris. Are you getting the same?
Yes, I'm getting the same. Yeah, it keeps getting very soft and to the point I can't really hear him anymore.
Okay.
And so what I would recommend, and to build off of what Chris just said, trying to figure his audio out, is that it's very in concert what I just said. If you have like this or in question, you could reach out to Chris. His issue is if you're looking for very specific data to high neutron detectors for sensors, this may not be the call, but realize that you should probably nail that down with more follow-up information with a technical POC. Chris, are you back?
Can you hear me now? This is Chris Grandy.
That sounds much better.
Yeah, I just called back in. Sorry, there's so many numbers to dial. Okay.
Okay, are we ready to move on to the next one?
I think so.
Okay. What TRL is expected for materials that can be tested in metal, METL?
So I would say probably a TRL 3 or 4 would be the starting point for testing in metal. The thing we need to make sure is that we don't disperse material, foreign material around in the loop in metal. So that's one of the concerns that we have. But it could be TRL 3, 4 types of materials.
Okay, next question. Oh, I'm sorry, Brian, did you have a comment?
I was going to build on that just for a moment. The metal is a hot flowing loop. Is 300 liters? Is that right, Chris?
It's 750 gallons, so like 3,000 liters, somewhere around there.
3,000. All right, I have my units off. So anyway, the issue that we're struggling with is not putting something in there. Putting something in there that has any sort of degradation could be detrimental to the loop and the health of the loop. So those are going to be questions that anybody who brings a proposal forward is going to have to address and get the confidence of the staff.
Okay, I'm going to loop back. They said the audience did not hear Chris's answer on tribology study and the high temperature liquid sodium. Chris, could you repeat your answer on that?
Sure. I think the question was about seals and bearings, and the tribology associated with, I think, the bearings and perhaps the seals. And so the answer is yes. And so we are looking for better seals and better bearings that can work in sodium. So yes, that would be helpful to us.
Okay, development of thermal hydraulic test articles for gathering data for thermal hydraulic code validation in a prototypic environment. What kind of data and code particularly are you speaking about that you would like?
Right. So there are various codes out there that are used to understand the behavior of SFRs, and so you know, there's SAS4A, SAS-SYS, there are CFD codes, and there are other codes associated with that. And so there are folks that are interested in improving the validation of those codes, and so people could be conceiving of thermohydraulic test articles which could go into a vessel in metal, which would support the validation needs of those particular codes. And there are probably others also that are out there, but those are the ones that we know of.
Okay. Next question. Is liquid lead reactor included in this call, or is it just for liquid sodium? Is the collaboration with ANL essential for this work scope?
Right. So I think the collaboration with Argonne is important because what we're targeting are experiments that are going to go into metal or enhance or using technologies to enhance the capabilities of the facility itself. Regarding, there are technologies which both the SFR and LFR share, like under sodium viewing can be used, I believe, in both technologies. And so a person could propose technologies which would go into LFRs that would be then tested in sodium.
Chris, Brian, what about INC sensors, other areas like that?
Yeah, that could be another area too, like flow sensors and so on, which could be used in both technologies.
Okay, at this time, that is all the questions we have. Let's wait maybe on the line about another minute or so, just a few minutes, seconds.
Julie, we may be able to move on to the RC-5 presentation and then take any questions for RC-3 after that presentation.
Sure, let's do that. Go ahead, Brian.
second here. All right. Am I ready to roll on this?
You are ready.
Okay. Well, good morning for those of you who are just dialing in. We are about to launch on the RC-5 call, specific to molten salt reactors. Again, these university proposals we find them to be very valuable. I'm going to walk through half a dozen or so slides. One thing I would tell you to pay attention to is our mission objectives, very specific to, and they're very much different than the fast reactor call. The fast reactor program is a bit more mature than the molten salt program is. The call for the MSRs is a lower in the TRL, but we're also resurrecting a lot of the technologies that are, again, are 50 plus years old. The technical POC on here will be Luke Walls. I'm hoping he dialed in. I don't know, Julie, if you can verify that or not. But while you're doing that, I'll go and continue on the presentation. Slide 2. Molten salt strategy. This is very big for us. Assist in a near-term deployment of MSRs, both salt-cooled and salt-fueled concept by establishing viability, developing needed research capability, enabling technologies, reducing costs, and accelerating development to facilitate industry success. Again, you'll see very similar to the SFRs. Our coordination with industry on these technologies are extremely important. Slide 3, this is not an inclusive list and is not to mean promoting any of these organizations, companies at all. It's just to give you an idea. It's a little bit different than other technologies where the range for the MSR are very broad. They can use, as with Kairos, a pellet bed fuel type of system. They can have a very large range, whether or not they're thermal or fast spectrum. And that was the whole intent of this slide. Slide 4, as many of you may be aware, I'm going to provide a little bit of history here. The MSRE was operated at ORNL from 65 to 69 and was primarily a primary reactor base with molten salt reactor. I'm getting a little bit of feedback. I don't know who that is. I provided some background here for the MSRE, but I would ask that for people who are interested in MSRs, you really should do a deep dive. And this is a perfect place to start is on the MSRE. I'll provide some slides that give you some hyperlinks to OSTI later, but you really should spend some time and do a little legacy or deep dive on this technology. Slide 5, MSRE is utilized U-235, U-233, plutonium-239. One of the benefits of the MSRs, as I presented on the one with all of the technologies, the industries, is the system to support MSRs is a very, very broad type of fuel. Makes it very attractive to a lot of the commercial space. I provided some data here for some backgrounds. The MSRE was thermal spectrum, 7.3 megawatts, ran at a high temperature, 600 plus C. It does give you a baseline of the type of fuel that was used, these lithium, beryllium, zirconium fuels. You should spend some time also. That was what MSRE does now. Currently, a lot of our experiments use FlyNac and FLIDE, and there are also manufacturers making their own versions of these that you may be aware of. The new interest in MSRs, fast spectrums, that you'll see from some of them, thermal spectrums from other. As we've talked about, they are liquid and salt cooled fuel systems. They have various plant sizes on these. The MSR technology can be appropriately sized from what we call sort of the micro space into a large reactor space. And of course, it has a diverse market because of all these potential sizes and heats. What we're asking for here is pump scaling technology for MSRs. The call is very specific. As I've identified in a previous presentation, I'll reiterate here, having the infrastructure to develop hardware and components is very critical to a lot of our commercial vendors. While industry is also going down that path, we're finding that the cost for first of a kind is magnitudes higher than what would be COTS commercial off-the-shelf technology. So we're hoping that we can tackle this through some knee-ups and do some specifics on how to develop some of these pumps to kind of knock them down. Proposals are requested to develop and demonstrate pumps that can serve as a technology model for future MSRs. And we've listed some key engineering challenges here. Unique materials, although they do not have to be. High temperature operations, that's something that has to be considered because all of the MSRs are running pretty hot. Complex chemistry and impact on corrosion issues, access for inspection and maintenance, and radioactive fluids, surrogate data testing. Important features include capacity ranges that are relevant for MSRs and FHRs, design suitable for repeated sealing for thermal cycling in conditions above 500 C. And one of them, I will tell you, we've had issues with that even in a current commercial space. That's why it's there. Being able to disassemble and reassemble these things are very important. Assembly methods that address removal, inspection, and maintenance. So just to spend just a second on the assembly methods, it is not only the method, but also how many times can you cycle a product? Is it a few, 5? If it's repetitively torqued, does the risk for deterioration go up? So it's not only a method, but it's also for, I can't put enough emphasis on the maintenance, the inspection and maintenance part of it, really knowing what the limitations of some of these things are as we're testing them. As I said earlier, I would provide a website for OSTI. For those of you who are aware, OSTI can be a very complex issue or database to go through, but it's still very valuable. It's a repository for a lot of our studies and reports, a lot of historical information. I've provided a link here that provides a little bit of background over some of the information that's in there specific to pumps. I also would stress that when you're going through this and you're going to submit something, to work with Lou Qualls on this, and I'll provide his technical information. Right. David Holcomb is the technical POC on this. I keep referencing Lou Qualls. He is the National Technical Director. David is very specific into the technology development. Lou has an overall breadth of the industry needs, the calls, how the program matures and develops. Again, David and Lou are more like hand glove. If you want more specifics to technology, you probably should reach back into David. If you want to understand where some of these technologies are going to fall in the industry, that's probably a specific that's more a function of Lou. Again, here's the email addresses for us. We can be reached at either email or phone numbers. I would stress that if you want to send me something, please send me it via email, because that's usually the best way to contact me. With that, Julie, I'll kick it back to you for potential questions.
Okay, I see David Holcomb is here with us, so I'm going to try to unmute him. David, it looks like you're self-muted. If you can unmute yourself. And I'll see,
okay.
I didn't see.
I believe I'm unmuted.
Great. Okay, and I didn't see Lou. Let me look one more time.
I don't think it's on. We spoke just before the call, and he asked me to be on it, so.
Okay. Okay. So most of the questions have to are asking about different things that are of interest. Are you okay with me asking those this time again?
I am. I will
Okay.
put out the general statement real quick is that the details of a proposal prior to somebody submitting them should be vetted with David or Lou. I've provided it, their contact information. I just don't want people to waste time if more details, or maybe there's a paradigm shift, or there's some information sharing that can happen. So people should be very active in reaching back to the technical POC. With that, I'll give it back to you, Julie.
Okay. This is similar to the RC-3 question. It's for RC-5 and pump development is bearing and seal development and high temperature tribology of interest in this call.
So I'll give you the short answer, absolutely. More detailed, if David wants to say something, please do.
You have to get into the specifics on there. The call is pretty self-explanatory on there. It's a pretty focused things. You need to be able to relate what you're doing to how this is supporting advancing the TRL of pumps for molten salt reactors. Yes, these are component technologies. Explain how it fits into the call.
Okay, next one. Are you interested in developing new materials or only using alloys available in the market, such as Hastelloy N?
So, David, I'm going to throw something in here. The program, we are not against new materials. The question really comes into play is the life cycle that it takes and the time it takes to develop what people call a new material. Now, I would ask if they're going to, I'm not sure when they say new, if they're talking about something that is not in the ASME quals that may be closer to a maturity path versus something that is brand new. Again, it would really fall back to what they're talking about and the details and the time horizon of which they're promoting something. David?
Yeah, it's just you look at what the purpose too is. I mean, if this is a new material for a gasket, it's not exactly a boiler and pressure vessel code use on there, but you certainly need to have enough knowledge of it so you could standardize it so someone could buy it. So that'd probably be an ASTM type standard on this. So yes, we are interested in materials that support being able to connect and disconnect your pumps, as well as just extending their lifetime.
Okay, for 5.1, is high temperature fretting, wear, and contact fatigue of interest?
David, I'll let you take that.
We have not seen enough examples of pumps running to go ahead and say that we saw a lot of fretting and wear. It is, if you can make an example and show that you're thinking that contact fatigue is actually a stressor in some pump design, then of course we're interested in that. We are certainly hoping the pump tips don't actually touch, so that would not be a source of contacts, and that would say, in the bearings, you would of course be interested in contact wear and bearings for pumps.
Okay, how are these important features listed in slide number 6 related to MSR pumps?
Well, I'll take this on. David, I don't know if you can look at them, but high temperature operations is certainly one. Complex chemistry and impact on corrosion rates. I would also throw that erosion or issues in there also when you're dealing with potential mass and movement. Inspection for maintenance when we're installing and removing pumps and being able to have a pump that is it's viable. You can look at it and understand what's going on with the pump since it doesn't have essentially life cycle. It's probably a first of a kind. Also, I would go back to important features include repeated sealing with thermal cycling conditions. That's a huge thing. And as I said before, the last item in there, removal, inspection, and in maintenance. What is the inspection process? How do you maintain these? Are they maintenance because of the last point under radioactive fluids and you have flowing radioactive material? Is there a maintenance process, or is the process to just cut, dispose of, and put a new one in? So I think those are pretty specific to the call for pumps. David, you have anything?
I think you pretty well hit it. The only other thing I think is worth mentioning is that you might start with a small capacity range, because there are several uses for smaller pumps, particularly in early phase research to support demonstration loops. You can't currently purchase commercially small scale pumps to support loop testing. On the other hand, you would like to have the technology capable of scaling so that it would support relevant things for at least micro scale reactors, if not larger scale reactors.
Okay, are you looking for like one more like one technical aspect of pumps, or are you looking more for a project that results in a whole new pump design?
So I'm guessing the question is saying, are we looking at improving potential current designs or something innovative, revolutionary?
Right.
I would say that either one of those are fine with us. Again, it goes back to the details. Right now, as David has alluded, and I've said, the infrastructure to support mass manufacturing is lacking. So to build on a current design, I think, has challenges as much as an innovative design, because current designs may be built for different type of systems, liquid flowing systems, but those don't necessarily mean that they're going to work or be the best choice for an MSR because of the radioactive materials that are going to be in the fluid and also the corrosion issues by the salts. David?
Oh, I fully agree with what Brian has to say. I mean, that we are certainly, if you have a revolutionary improvement, we're interested in it. But if you can sort of improve the engineering parts of things, so I can do better maintenance, better inspections, and make a stepwise improvement in current pumping, we are also interested in that. And yes, it is difficult to evaluate two different proposals. I wish that we had more money, but we are interested in both your overall improvements and specific technology improvements.
Okay, next question. Are canned rotor magnetic bearings pumps of interest?
David?
There's a current ARPA-E call, the proposal project that is working on this. So yes, canned rotor magnetic bearings have some very desirable capabilities for molten salts because they're sealed and they have no contacts, so they might go for a substantial period of time. I think your biggest challenge on this is that this is a revolutionary type of improvement, and this is a limited amount of time and budget. If you can do a canned rotor magnetic bearing pump in 3 years for $800,000, yes, we're very interested, is the basic message. I suspect that you may end up needing to work on some specific aspect of this.
Yeah, my only addition to that, if I could just pony up, is that while this is specific to pumps, I hope it was clear that we're really trying to support not just expanding research in a over the side of the fence, but really its commercial application. So some of these types of designs, I would ask for them to be very specific on their use. It isn't a one-off. It's something that can be replicated and used in the technology and potentially upscaled for different types and sizes of MSRs.
Okay,
Julie?
I'm sorry, go on.
No, But back to you.
Oh, do experimental activities have to be done in molten salts?
I'm trying to figure out why they wouldn't. David, maybe you have.
Yeah, I'm also a
more
little bit confused because I have a hard time figuring out how you're going to validate performance for a pump without using the material it's pumping. And if you can explain, in your proposal how you're going to accomplish that, then probably you don't have to. But I just find it difficult to imagine that you're going to be able to validate, a seal, whether you're going to get leaks of molten salts without using molten salts to see whether they leak. So conceptually, it's okay. It's just, I think it'd be very technically difficult to accomplish.
Yeah, I agree. And I think once you get beyond what we would call sort of the introductory of MSRs with FlyNac and Fly, unless you can provide an argument that's very similar to what they would be able to provide in one of those types of materials, I would really struggle to understand why this wouldn't have, it probably would have other issues for us to address.
Okay, I think this might be our last question. Will tests utilizing actinide-bearing salts be prioritized?
David, you want to answer that one first?
We don't think that the pumps have an awful lot to do with the actinides unless you think that something is going to plate out in there. So there's not a particularly strong reason, except perhaps density matching and for in a natural uranium salt. We are certainly not at this level of a proposal for a university expecting you to put highly radioactive materials in your demonstration. And so pumping a material with less than 1% uranium in it doesn't look an awful lot like pumping a material without that 1% uranium in it. So there's no real crying need that you have to put actinides, and certainly things like transuranics are beyond the scope of this call, the capabilities. Yeah, we'd love to see them, but we don't think it's realistic.
I would agree with that. I was trying to think about it when David was talking. I think if you came up with this kind of combination of a couple of questions and you had some pump that was either legacy or innovative, and you were able to design it in a way very quickly and low cost, and then you had the ability of throwing some fuel in it, of course we'd look at it. I don't think it's, as David alluded, I don't think it's very practical for the time slot and the money that somebody's going to do that unless they have one already very well established in their system already.
All right, thank you, gentlemen. I'll send it back to Drew now.
Thank you.
Okay, goodbye.
Okay, thank you, Julie. We will take a break for about 15 minutes. Oh, excuse me, about 45 minutes. And we will be back online at 11:30 a.m. Eastern Time for the used fuel disposition work scope titled FC4. Until then, thank you.